Today we're joined by Pushmeet Kohli, who is the head of our Science and Strategic Initiatives team.
We are not looking for something which is an incremental improvement. We are really sort of looking at goals which are going to have a transformative impact.
One of my general takeaways is like the pace of science advancement inside DeepMind is crazy.
We will have more and more powerful models, which will be more general, which will be able to do many more interesting things. Yes, we will have this amazingly powerful general intelligence. The question for our team is, what will we use it for?
I love that framework. As we get intelligence, how do you actually wield intelligence to solve these problems?
Our job is to leverage all that progress, add to it to solve the next impossible thing for the benefit of humanity.
Hey everyone, welcome back to Release Notes. My name is Logan Kilpatrick. Today we're joined by Pushmeet Kohli, who is the head of our Science and Strategic Initiatives team. Pushmeet, thanks for being here. Excited to chat all things science.
Yeah, thanks for having me, Logan.
Let's dive in. I feel like we have, one of my general takeaways is like the pace of science advancement inside DeepMind is crazy. Like we have all these new alpha programs always coming out. There's tons of stuff, and hopefully we'll be able to deep dive into a bunch of these today. But do you want to, for folks who have maybe seen some of the launches, you want to give us an overview of perhaps maybe like the 3 most recent alpha science launches that we've done?
Yeah, so very happy to. So I think even in the last 3 months, we have been having a number of sort of launches come up. The first one was AlphaEvolve, our super optimization, code optimization agent, which really showed a lot of impact in solving a number of optimization problems, from optimizing data centers to speeding up Gemini training itself. Then came AlphaGenome, which was our model for deciphering the human genome, right? And that was very exciting. And then very recently we had AlphaEarth, which was another sort of geospatial model for sort of shedding light on what's happening on the planetary scale.
I love that. I know you'll get a bunch of ignorant questions for me because I have a much better worldview of the Gemini ecosystem than I do of some of our science work. But maybe to start, like for Alpha Earth, can you sort of double click as far as like what if people miss the headlines, like what is it? Why should people be excited? What problem is it solving? All that stuff.
Yeah. So if you think about Google Earth, what Google Earth was able to do was able to integrate all this amazing information about our planet and making it accessible to everyone. What Alpha Earth does, it basically again sort of combines a lot of information that has been captured by remote sensing satellites and so on into one single representation. And what this semantic representation is then uh, able to do is you can use it to propagate information that you know about a specific sort of attribute of a location. You might say, well, I'm looking at habitats of certain species, and I have found this species in this particular position on the map, right? Now propagate that and try to reason about where else will I find the same thing, right? So it essentially captures the semantics of what's happening at the geospatial sort of a level at the planetary scale.
I love that. How do you think about, as you described, just even those most recent 3, there's like there's a big range of that work that's happening. I think for your team, but also just generally for DeepMind, like how do you think about what of those problems are we tackling versus what are they not? Because they feel like very, like it's almost surprising to me that we'd be able to make progress in such different domains. So I'm curious to double click on how you think about that framework.
Yeah, so I think if you think about the whole spectrum of intelligence, you can categorize it into maybe 3 broad categories. The first category is our intelligence competencies that everyone sort of has, most human have, right? All of us will be able to look at an image and say what is in that image. We will be able to recognize the characters in the image. We will be able to read handwriting and so forth. Then there is a second category of intelligence, which is more focused on expertise. If you see someone's symptoms, can you figure out what's happening to them? Can you make an accurate diagnosis? So that's expert level intelligence, right? Similarly, if you are given a specification, can you write a program that implements that specification? Again, that requires a lot of expertise. So that's expert level intelligence. Now, then there comes a point where you have certain tasks which maybe no human can solve. If you give a sequence of amino acids, which is a protein, and if you give that protein sequence to any human, like one of the smartest human being, and say, can you figure out what is its 3D structure? We'll not be able to do that just by reasoning about it, right? It takes before we released AlphaFold, it used to take almost $1 million, and sometimes multiple years to figure out the structure of a single protein. And so with AlphaFold, we were able to do that in a matter of a second for the cost of a few cents. And so those are the kinds of competencies that our science program tries to aim for, things that are not possible today, which and really sort of building intelligent systems that can solve really the unknown.
We were talking before off camera about what the sort of the different levels of impact from all these different initiatives. And I feel like actually the three that we released most recently are great examples of like the variance and the level of impact across like different categories in the ecosystem. So I'm curious to also double click on this like framework of how we think about impact from all this different science work.
Yeah. So I think essentially the science and strategic initiatives unit, we really focus on transformative impact. The important piece is transformative impact that will benefit humanity. And what is the impact type? The impact could be scientific, it could be commercial, or it could be social impact. I can give you sort of examples of all these three different categories. So the exemplar for scientific impact is AlphaFold. I mean, everyone sort of knows about it. It was essentially something that we sort of pioneered, one of the great success stories of modern AI, where this amazing fundamental root node problem in science, which has so many different applications from drug discovery to understanding human health to understanding, frankly, life itself, sort of was open for many, many decades. And AlphaFold was this remarkable system that could, from a protein sequence, figure out what is its 3D structure. And it made that big breakthrough at the height of the pandemic in 2020. And even in the last 4 years, like there have been, it has been used in so many different places, and the scientific impact has been amazing. It was recognized as one of the most cited scientific papers, and won the Nobel sort of prize last year for Demis and John. And so you can imagine in such a short span of time the amazing impact that AlphaFold had in the scientific community. Now, moving on from AlphaFold, I mean, of course, it had commercial impact as well because we spun off Isomorphic Labs, which with the specific mission of really revolutionizing drug discovery, and I think they are doing a very good job at that. Now, double clicking on the commercial sort of impact point, one of the agents that we released earlier this year is AlphaEvolve. Now, AlphaEvolve is a Gemini powered coding agent. It's not sort of giving you um, a solution for something that you do every day. It's it's essentially trying to do things which no computer scientist has been able to do. So imagine um, over the last 2 decades, uh, people have tried to make sure that how we optimize our data centers is fine tuned. And some of the smartest people at Google have tried to find out what are the right algorithms so that how do we distribute jobs to different compute clusters. And that is an incredibly important thing because you there's a lot of compute and monetary impact is to be had if you could refine this. And by running AlphaEvolve, not only did we make an improvement, but we made a very significant improvement. Almost 0.7% of the whole compute fleet we were able to save, right? And that's a huge sort of saving when you actually multiply it with the amount of compute that we use, right? Similarly, it was able to speed up Gemini training itself, which is a very important element. And now, again, although it was focused on commercial impact, it had amazing scientific impact as well. We ran it on a bunch of open maths problems, and for 75% of them, it found the state of the art solution, which the best mathematicians had been able to find. And for 20%, it went beyond them. So these solutions were not known. So that was sort of commercial impact. Now, coming to social impact, and a great example of social impact is SynthID. So SynthID is essentially our state-of-the-art watermarking system. Now, have been one of the pioneers of generative AI. And if you think about both the Veo launches as well as the Genie launch, which happened sort of recently, you could see the impact this technology is going to have. But there are sort of also risks associated with that, right? That in the information ecosystem, the quality of these models and the quality of these results are so much that it's difficult for users to even sort of see what is synthetically generated versus what is natural, right? And this was one of the key sort of elements. Like for Google, it's really important that users understand what was synthetically generated and what was sort of physically represented the physical sort of world. And so SynthID was born out of that problem motivation. And I'm very sort of happy and proud to say that we are one of the first sort of companies that every Gen AI content across all modalities at Google, whether it's text, whether it's images, whether it's videos, is watermarked with this imperceptible signal, which is robust to different transformations of those signals and can be detected.
Yeah, I don't think people appreciate how difficult technically of a problem it is to solve SynthID. So happy to double click on that. But just in general, I feel like part of the challenge I imagine for your team, and I'm curious to get your reaction to this, is just like you have on some ends of the extreme, AlphaFold and like Nobel Prize science impact. On the other hand, you're probably saving Google billions of dollars by, the 0.7% improvement in fleet efficiency and Gemini training in general. How do you like, from your team's perspective, is it just like there's all of these huge opportunities, just like low hanging fruit sitting everywhere, and it's like, we can just go tackle a bunch of these? Or is it like, are you actually like really having to, turn over a bunch of stones and like be really do a whole lot of exploration to find these places where AI can have a huge impact, and like Google is well positioned to solve? I'm curious how that like initial process works.
Yeah, so I think that's a very good question, and as you can see, like there are a lot of problems that we could solve, but we sort of think about it in a very specific way. I think in terms of the what we try to solve, there is a very simple sort of algorithm that we follow. The first point of that algorithm is to make sure that the problem is going to have transformative impact and is going to be feasible, right? So we are not looking for something which is an incremental improvement. We are really sort of looking at goals which are going to have a transformative impact, whether it's scientific, whether it's commercial, whether it's social, but it needs to be sort of transformative, and it needs to be feasible in the sense that everyone in the community believes that it's going to be transformative and it's going to be achieved at some point of time. We don't want to work on time travel, right? We want to work on things which are actually going to happen. So that's the first requirement. The second requirement is that there should be sort of almost consensus that no one will be able to achieve it in the next 5 to 10 years. So it needs to be hard. If someone is working on it and thinking that it will be solved in the next sort of 6 months, then it's not a problem for us, right? Like our team is particularly focused on these things which are incredibly hard and that require multidisciplinarity, which require the best AI research coupled with the best engineering, coupled with the best compute, the best data to come together to solve this incredibly hard problem. And then the third requirement is we think that the consensus on in the community that this is going to take 5 to 10 years is wrong. We can do it in half or one third of the time. If those three conditions are met, we take it on.
Yeah, that makes complete sense. I'm actually curious through this framework how like how does AGI fit into that? Like is there a world where like and actually as you think about these, like you're solving very it seems like domain specific problems and like is there a world where this like intelligence sort of generalization makes it easier to solve these problems, or like you still think even in a world where we have really advanced general purpose technology, from an AI perspective, you'd still need to go and like build a bunch of bespoke stuff or leverage those systems in a very specific way. And like the Gemini Alpha Evolve one is a great example of this, maybe where it's like the model is really good and then you can supercharge it in a bunch of ways to help solve some domain specific problem. Is that
Exactly. It's exactly. The idea is that progress will happen in AI, and we will have more and more powerful models, which will be more general, which will be able to do many more interesting things, right? Like when we were thinking about reinforcement learning and being able to solve search problems, right? Whether it was AlphaGo, whether it was AlphaChess, and so on. Um, there is development that is happening, which is making things possible that was not possible earlier. And our job is to leverage all that progress, add to it to solve the next impossible thing for the benefit of humanity, right? And the key question is, yes, we will have this amazingly powerful general intelligence. The question for our team is, what will we use it for? The specification, the problem that we will that we will apply this amazing technology that will eventually sort of be created.
Yeah, I love that framework of like as we get intelligence, how do you actually wield intelligence to solve these problems? And this is my plug for the DeepMind team in general, which is I think so many of the labs, and I think this Demis said something like this, like so much of the narrative about AI right now is that in the future it will be used for scientific impact, and I feel like DeepMind historically is the only place where like it is actually today being used for scientific impact across the ecosystem. I feel like a bunch of the examples you gave are like the proof is in the pudding that DeepMind is doing this work, which is awesome to see. I'd love to, again, through my worldview of like, I spend much more time thinking about Gemini stuff than I do our science initiatives, just because it's closer to my world. Um, how are those two worlds connected, like the science unit and the work that's happening in across Gen AI and across the Gemini world? Like, how do you collaborate with those teams? Like, how does the technology transfer happen? You talked about AlphaEvolve, where some of the foundational components are the same. I'm curious to hear that story.
Yeah, so I think this is the other thing about DeepMind, I think, and Google DeepMind, and which is the culture, which is extremely collaborative. We collaborate very, very closely with Gemini. I can sort of give you many, many examples, whether it's the sort of um, collaborations on the base architecture as to what is the next sort of generations of architectures that we should be developing that would make our model, which will make Gemini be able to sort of understand and perform much better on scientific tasks. So this is one sort of area that we sort of collaborate on. We collaborate on evaluation. What are the next types of things that we should evaluate the system on to really see how that's making progress? So, and then we also collaborate on data, right? What kind of data should we train Gemini on so that it has a really good understanding of these amazing specific domains that we want to go after, whether it's sort of biology, whether it's chemistry, materials, sort of code, cybersecurity. Like, we really want to make sure that Gemini has a good handle of all these different types of domains. And then, of course, there are projects that we work on together. For instance, the IMO project, like, has been a collaborative project from Gemini and the science team. And as part of it, we first worked on alpha proof and alpha geometry, and then this year we basically learned a lot and then tried to integrate all of that into the Gemini deep think model, and we have got this amazing sort of result, which really sort of shows that both the generality as well as the pioneering aspect of sort of being able to go for that very ambitious challenge can work for both kinds of models.
Yeah, let's actually double click on this example because I think it's perhaps like one of the best versions of this story, which is I think the original. So we got like the IMO, I think it was silver medal. We were like 1 point away from gold last year. That was a domain specific model that like wasn't the base Gemini model that was available to the world. And that actually was, I don't remember, was that like a custom alpha? Was it an alpha version of the model, or
Yeah.
do we brand it in that way?
Yeah, so it actually was a collection of two models. One was called Alpha Proof, and the other was called Alpha Geometry.
Got
So
it.
Alpha Geometry, by its name, you can sort of guess that it was specifically focused on solving geometry problems. Um, and then there was Alpha Proof, and Alpha Proof had this very interesting sort of aspect, is that there was an underlying LLM in Alpha Proof, but what it was doing is essentially searching in the space of all proofs, right? So it will formulate the problem. It will take your maths problem, convert it into a formalized problem specification in a domain specific language called Lean.
Hmm.
And what this sort of language is able to do is it's able to give you proofs. If you solve the problem, you will get a formal proof, so that you know that it's actually correct. That if you find the solution, it is actually correct.
And just to clarify, for folks who aren't familiar with like, and I know pretty much nothing about formal math proofs, so I'll put myself in this camp. The nice thing is that it is like, um, it has this verifiable component. So like you actually
Exactly.
know, it's not like a question of like, if it runs, then like essentially you know that this thing is like a true
Yeah.
version of, it's like accurate,
It's yeah,
basically.
it's given a problem statement, and it's told to solve to prove that problem statement. And if it finds the sort of a proof and says, "Oh, I've proved this," then it's actually correct.
And is it always, just to double click on this, anytime you have a proof like that, is it always like mathematically, like I'm thinking about code as another proxy. Like
Yeah.
I could write a bunch of like horrible programs that are like garbage code to solve some problem, and like it's not like I wouldn't. It could still be very like a bad solution. Is that the same in this like proof world, or like if it solves the problem, it doesn't matter if it's like not elegant or something. It's like everyone's happy with it solving the problem that way.
Yeah, so I think mathematicians would tell you that maths is about elegance. So of course, basically, the proof can be elegant, or the proof could be like really, really long. And
IMO actually from the actual competition does like grade based on the elegance to a certain extent, right?
it sort of grades on both aspects, right?
Okay.
Like, it's not as if you just say, "Oh, here's the answer." You will not get full marks.
Yeah,
You have to actually show how did you arrive at that answer,
got it.
right? So in that sense, basically all our proofs were given full marks because they showed how you arrived at that answer in a very specific way. Now, whether those proofs are understandable by a mathematician or how difficult were they to be understood by a mathematician, that's another question.
Yeah. So we have those two models last year. Can you tell any part of the story of like how do we get from those two domain specific models, alpha geometry, alpha proof, to now DeepThink, built on top of like Gemini 2.5 Pro as like a base Gemini model? Is there like a bunch of synthetic data generation that then feeds into the mainline model training, or like what's the technology transfer in that direction to mainline Gemini?
Yeah, so I think the first sort of element is that Gemini itself has improved a lot, regardless of what we incorporated, right? Sort of the deep think, the thinking versions are generally much more advanced in terms of their reasoning. Now, in terms of what we learned from Alpha Proof is Alpha Proof had this amazing ability to find valid proofs. And as we sort of said, that when it finds a proof, it is valid. We know it's correct. So now you have this amazing ability that you can generate sort of hundreds of thousands or even millions of problems and try to solve them using alpha proof. And wherever it's successful, you know, here's the problem and here's a valid solution. So now you can generate training data. So this is training data that can be used for training Gemini, saying, "See, alpha proof found it. You should also be able to find it," right? So it's amazing. Sort of, it's an amazing data generation strategy
Yeah.
for training the next generation of Gemini.
Something that to delve into this a little bit more, something I've struggled with is how that like math skill like transfers to general domains. And I'm curious if you have a point of view on this, but like I don't intuitively, when I hear as like somebody who wants to build, like I'm building a customer support app, or I'm building, even like a code generation app, or like some vibe coding app or whatever it is, models being good at math does not intuitively, in my mind, translate towards like, I should care about this as someone who's building with the technology. So I'm curious, like, is there some underlying principle of math that like makes it so that it's interesting, or is it there are math use cases and we should make the model better at math if we can, but we don't actually expect that to generalize across other domains?
Yeah, so I think that that question itself is a research question in the sense that there's no sort of conclusive answer. It's very much an empirical thing at the moment, right? It could have a huge impact. It could not have it might not have an impact, but it's all analytical and empirical, right? We have to really see if we add this data in. Of course, it should have sort of have impact in maths, but which other sort of abilities it impacts, that is something that we sort of look at very systematically through ablations, saying, okay, if we add this, what is the effect? If we delete it, what's the effect on various different evaluations, right? And then that's how you get the real sort of picture.
Yeah, I feel like instruction following is maybe like as you're describing what alpha proof and alpha geometry do in this like explainable how to solve a problem. I feel like that's like that sort of generally tracks, I feel like, to a lot of language model capabilities where you want it to, here's an example of
Yeah.
me doing something in practice, follow a bunch of examples like this, generalize to other random variables that might show up. So I do feel like I could grok how that might be beneficial generally. Just to double click on this, I think part of the story of this IMO achievement is that we're actually not using a domain-specific math model anymore. The capability is now generalized into the DeepThink model. And can you double click on this? Because I think that's been one of the cool things about this about the DeepThink moment.
Yeah, exactly. I think what happened this year is that Gemini made a number of significant advances in one go. So not only did we move from silver to gold, but we did that using natural language specification. So the problems are not now translated in a specific mathematical language like Lean. They are just normal, your English language. Anyone can sort of specify them. And Gemini could take those problem specifications and solve the problem. The second thing that has happened is that this is almost a generally available sort of model, not a very custom alpha proof model that was only available sort of within DeepMind and required a significant amount of search. It is almost a model that can be used by anyone on the planet. So I think these are amazing sort of transformations that have happened even in just the last 1 year.
Yeah, I want to double click on this, how we make the technology available to a much broader audience. But I just, as another point, like we announced Genie 3, and this was my immediate reaction. And I think the world's reaction is like, we want to use this stuff. And I feel like it's so cool that for DeepThink and for this IMO Gold model, we have it in a way that people can access it and like experience the model themselves and play around with it. But tying back to some of the other initiatives, and I think like on the IMO side, like good example deployed through the Gemini app, and customers can access it there. For some of the other initiatives that we're doing across the science spectrum, like how are those actually like showing up in the world? How are people accessing them? Like what's the deployment story for those things?
Yeah, so I think this is a very good question. And from the very start, the whole initiative and the whole unit was focused on the idea that we are not just making these breakthroughs. Part of it was to make this available to the world to have that impact in the world. So, to give you an example with AlphaFold, it's not that we just created this AlphaFold system and kept it with us, right? We actually made it accessible through an API. And what we did with AlphaFold was we, in fact, f- predicted the structure of almost every known protein on the whole planet, and then we sort of placed it in a database called AlphaFold database, and now anyone on the planet could sort of use it. So that um, researcher in Brazil or in Africa who was working on some neglected tropical disease, uh, who had no sort of way to get a structural characterization of the protein target that they were interested in, now can just put their protein onto a web page, click a button, get the structure. And that sort of completely democratizes sort of AI. And we are not just doing it for AlphaFold. We have done it for almost all the models. Like AlphaGenome, we built a custom UI for allowing researchers to figure out what is the effect of mutations or variation in the human genome. And so again, sort of all these models have required innovation to bring them to the broader scientific community so that they can eventually use it.
Yeah, through this thread of bringing some of this innovation to the scientific community, I want to talk about co-scientists for as long
Yeah.
as we can because I feel like people are super excited. I'll make one general comment, which is you not on your team who's working on co-scientists. I did had a conversation with her right after IO, and we were talking about what is what is IO? I think it was what does IO 2030 look like or something like that. And we were just sort of as one of the like thought-provoking questions, and she made the comment that like IO 2030 is like hopefully Google announcing like a major scientific breakthrough enabled by AI, and specifically coming from a team that doesn't look like it's not like a bunch of PhDs. It's like someone around the world who doesn't fit the bill of who you would expect to make a major scientific breakthrough, making it because they have AI at their fingertips. So through that lens, I'm curious what your reaction is to that, but also like how you think about where co-scientist fits into this um, this innovation framework that your team has.
Yeah, so I think like a broader sort of goal that our team has is we want to have a Nobel level scientific, we want to enable Nobel level scientific breakthroughs. And our strategy to do that, for doing that in the past, has been to really pursue some of those things individually, right? So AlphaFold was a Nobel level breakthrough. It was awarded the Nobel Prize. Now, in fact, you could argue that many of the predictions that AlphaFold had made about structures of new of proteins and so forth individually sort of constitute real sort of breakthroughs. But I think if you look forward, what you will see is that AI, we want it to be a tool that enables scientists to have to make many more of these amazingly transformative breakthroughs. It accelerates the process of scientific research and sort of being able to innovate much faster. So, and in that sort of context, AI co-scientist is an incredible example because what it does, and it's sort of counterintuitive in some sense. It sort of simulates the scientific process. So, for people who are not familiar with the AI co-scientist, it's essentially a multi-agent setup where Gemini now plays multiple roles. The role of a hypothesis generator, the role of a reviewer, the role of a critique who is critiquing the ideas. So it's generating ideas and also critiquing those ideas. It's ranking those ideas. It's basically editing those ideas. It's creating all the sort of roles that are there in the scientific research ecosystem, and it's doing it by itself. And somehow the ecosystem, when it works like this, when this multi-agent system works like this, it produces amazing new insights into uh, into these problems which are extremely important. So, and we have sort of tried it on a number of different important problems, from antimicrobial resistant for antibiotics. I mean, that's a really sort of important a domain, to many other sort of diseases. And like the scientists have been amazed at the hypothesis it has been able to generate. So I think agents for science is a very cool area that I think we will see a lot of progress in.
Yeah, I'm excited. I have one more question, but the one of the anecdotal examples I heard about co-scientists was a scientist got access to it and was playing around with it, and then one of the hypotheses that had been generated, they were like, "Oh yeah, we were literally trying out of the lab last week," which is like crazy that there's like that much overlap in how they're thinking about
So,
something.
so the story was that we had asked a number of scientists to give us problems that we should give to co-scientists. So, one of the professors at Imperial, in fact, in London, he sent us a prompt. He said, "Okay, here's the problem. Try to solve this problem." And he was expecting some sort of simple solution or something that has already been tried and so on. And we sent him a report of the ideas, of 4 or 5 ideas that the system came up with. The first idea that the system had come up with was an idea this team had been working on for the last few years. and had just submitted for to a scientific journal. And they were completely convinced that somehow Google had got access to their paper and had leaked the paper, or it was somehow in the training set. And so for a lot of for a while they were just saying, "How did you get my paper?" And when we convinced him that we did not get his paper, and in fact, look at the other ideas that we have shared, and he said, "Oh yeah, the other ideas also look extremely novel. I should try working on them." So I mean, it's amazing what these systems are able to do.
Yeah, that's crazy. My final question, how through the lens of all of this question, like, do you think future facing will end up with something like a API for science? And I think just like the tailwind that's really interesting that's happening is like the level of expertise required to like make significant contributions across like coding is the relevant example right now, where it's like becoming easier and easier to build software and generate, and like who is building software looks different than what it looked like 10 years ago. And I can imagine something like that being true for science. And I'm curious through that framing, like, does an API to help more people contribute to science make sense?
Yeah, absolutely. I think the key question, as with coding, and will be there with science as well, is the specification question. How do you even define the problems, right? I think there's a lot of uh, sort of deep insight that goes into what is the program supposed to do,
Yeah.
right? And sort of writing that, and we will need, as a AI community, we will need to build these amazing interfaces that will be able to more naturally capture what developers are trying to do, right? And so in some sense, that is extremely important for the role that you are playing in making sure that we are exposing the interface sort of correctly to the developers, and we are also getting feedback from the developers as to what is it that they expect, what are the types of things they want to specify. It's going to be extremely important so that we build that efficient communication channel between the AGI and the developers.
Yeah, H2 2026 plan, put in API for science and AI Studio will make it happen. Pushmeet, this was a ton of fun. Thank you for sitting down and having this conversation. I'm excited for more alpha releases and more science work coming out of your team. So thank you very much.
Thanks, Logan.
Yeah, of course. And thanks everyone for tuning in. And we'll see you in the next episode of Release Notes.